if you can't factor the equation? All right, we've been working with factoring, and we solved using square roots. But you can't solve something with square root if it has a squared term and an x. Right? But what if you can't? So we learned two methods. What if you can't use either one of them? All right, so here we want to write the equation in the form ax squared plus bx plus c equals 0. All right, so we do have to get this in a standard form by subtracting 4 from both sides. So now we have x squared plus 8x minus 4 equals 0. All right, and a is 1, b is 8, and c is negative 4. So 1 times negative 4 is negative 4. We need two numbers that multiply to negative 4 but add to our b term of 8. All right, so we want to factor the equation completely. What two numbers have a product of negative 4 and a sum of 8? Well, since b is positive, the larger term has to be positive. All right, so here are the factors of 4. Negative 1 and 4, and negative 2 and 2. That's it. All right, 1 and 4 and 2 and 2. All right, and if we make the larger term positive and we add them together, we get 3. And if we make the larger term positive and we add it together, we get 0, because there is no larger term there. So no two integers multiply to equal negative 4 but add to equal 8. We cannot factor this quadratic equation. We need another way. There we go. And here's going to be our visual reminder. b divided by 2 squared. We'll come back to that visual reminder, but just remember that. So this is an x, that red bar, and this is an x squared. So we multiplied x by x, in other words, x by x. Come on. You have to use your imagination here. Come on. Third time. I'll probably have like 3 of them all on top of one another. Like I said. All right, so if we multiplied x by x, we'd have x squared, the blue box. Let me get rid of this. And then we have our little unit, which will come up in our discussion here. All right, so come on. This would be x squared plus 6x. We have 1x squared, and we have 6 of those x's. All right, we're going to arrange them to create a square. But how many units? The little cubes. So imagine these are the unit cubes. You have the big flat 100, that's our x squared. The little rod, that's our x. And the little tiny cubes, that's our unit. How many units are required to complete the square? See if you can figure out, looking at the picture, how many would be needed. Have a number in your head. Got that number in your head? All right, so let's take a look. All right, so I'm going to do this. And I'm hoping for lines. There we go. And then I'm going to do this. Well, if I put boundaries there on the edges, how many units do you see? Well, if you see 9, you are correct. And I think it's below. Is it below or is it on the next page? It might be on the next page. So let's look at the next page. Yep, there it is. So how many units are required to complete the square? If we add in 9, we now have, oops, I don't want to show that part yet. We now have x squared plus 6x plus 9. And let's factor to show that that is a perfect square. All right, so if I had x squared plus 6x plus 9, all right, multiplies 1 times a is, let me write that down, a is 1, and b is 6, and c is 9. 1 times 9 is 9, multiplies to give me 9, adds to give the b term of 6. That would be 3 and 3. So we'd have x squared plus 3x, your group. There we go. Plus 3x plus 9, your group. Factor out the x, we have an x plus 3. Factor out the 3, we have an x plus 3, right? We divide 3x plus 9 by 3. 3x divided by 3 is x. 9 divided by 3 is 3. All right, so notice we have a common factor. So that's why we can, why the repeating becomes one factor. We can literally just factor out the repeating. All right, that's a common factor. It's a common factor for the x times x plus 3. It's a common factor for the 3 times x plus 3. All right, so x plus 3 is one factor. If we factor out the x plus 3, we're left with an x plus 3. And notice it's the same. So x squared plus 6x plus 9 factors to x plus 3 times x plus 3. Since we're multiplying something by itself, we could rewrite that as x plus 3 squared. So that is a perfect square. So 9 units made our figure here a perfect square. Let's look at another one. I think I have at least 3. We have x squared plus 2x. Let's put them together. How many units are required to complete the square? All right, so think in your head how many are needed. I think this one is easy. By the way, did you get the last one right? Did you know it was 9? But even if you didn't know that one was 9, I got a feeling you knew this one, how many were going to be needed in this case. And it was 1. 1 square was needed to complete our picture. Let's factor. So we have x squared plus 2x plus 1, right? And so a here, let's put it over here. A is 1, b is 2, c is 1. 1 times 1 is 1, so we need 2 numbers that multiply to give us 1, but add to give us our b term of 2, and that was 1 and 1. So x squared plus 1x, or just x, is going to be a group, plus x plus 1 is going to be a group. Common factor for x squared plus x is x. If we divide x squared plus x by x, we get x plus 1. No common factors other than a 1 for x plus 1, so we'll factor out the 1. All right, and so we can factor out the repeating x plus 1. That's a factor for both terms here. And then we have the leftovers, right? That would be left after we factored out the x plus 1, which is x plus 1. So notice they're the same. And of course, x plus 1 times x plus 1 could be rewritten as x plus 1 squared. Right? How about this one? We have x squared plus 8x. Let's artfully arrange them. How many units are required to complete the square? Think in your head how many might be. Got your number? Okay, so if you get it before, I draw in lines here, and let's put a boundary. And I draw lines going this way. And something here. So now the picture is x squared plus 8x plus 16. And it does factor to x plus 4 times x plus 4, or x plus 4 squared. By the way, did you notice there's a pattern to the factoring in these 3 examples? So x squared plus 8x plus 16 factors to x plus 4 times x plus 4, or x plus 4 squared. And then if we look back, x squared plus 2x plus 1 factors to x plus 1 times x plus 1, or x plus 1 squared. And then, where was it? There we go. Just one more page back. X squared plus 6x plus 9 factors to x plus 3 times x plus 3, or x plus 3 squared. You see there's a pattern there. We're going to use that pattern. Even if you don't recognize the pattern right now, I will tell you the pattern once we learn our steps. To completing the square. It is, after factoring, it is probably the most important way to solve, right along with taking a square root of both sides, because that's going to become a part of completing the square. So an equation in which one side is a perfect square trinomial can easily be solved by taking the square root of each side. That's what we did In the last lesson, right, we took a square root of both sides. A perfect square trinomial is a binomial multiplied by itself. So our solution strategy is going to be to force a perfect square trinomial of the form a squared plus 2ab plus b squared. Now you're thinking, we just can't go nilly-willy forcing things. You know, we had to add something to that to make it a perfect square. We can't just add things in. Well, you can for an equation, so long as you add it to the other side. So remember, in an equation, I can add, subtract, multiply, or divide by any number, so long as I do it to both sides of the equation. You do it to both sides, the equation still balances. So here's our steps to solve by completing the square. If a is not 1, we're going to have to divide both sides of the equation by a. In the first examples we're going to do, though, that's not going to be an issue. Right? Later on it will be. So you're going to look, if a is 1, you're going to skip that step. If a is not 1, we're going to divide both sides of the equation by a. Because remember, we're allowed to do that so long as we do it to both sides. Right? We have to get rid of, a's got to be 1. We have to get rid of any other coefficient by dividing. Otherwise, we won't have a perfect square. That coefficient's going to mess everything up. We're going to rewrite the equation so that the constant term is alone on one side of the equality symbol. So now we don't want it in standard form because, well, if we could solve it the way it was, right, we wouldn't need this method. But because we can't factor it, right, that constant term is of absolute no use to us. So we're going to banish it by adding it to the other side, and we're going to rewrite the other side to be better without that constant term. We're going to square half the coefficient of x and add this to both sides of the equation. Now think, what was the coefficient of x called? The coefficient of x squared was called a. The coefficient of x was called b. Hence the visual cue. All right? So you're going to take b, the b in the equation, and divide it by 2, and then square it. So just remember our visual cue here. And you might say, what if there is no b? Then you're not going to use completing the square. You're going to solve by taking the square root of both sides. All right, so all of these will have a b in them. And so we're going to take b divided by 2 squared, add it to both sides. That's the magic number that makes this a perfect square. And we'll go back and look at our diagrams to show you that our magic number was always b divided by 2 squared. That's the magic number that will make it a perfect square. We're going to factor the resulting trinomial as a perfect square. It follows a pattern. I will tell you the pattern. You're not going to have to use grouping here because there's a pattern every single time. And we're going to combine the constant terms on the other side. Now we're going to have a something squared equals a number. If you have something squared equals a number, right, you can solve by taking a square root of both sides. Right? Right, so let's go back actually and take a look at what b was and show you that each time we added b divided by 2 squared. So this one was the first one. Oops, well, it didn't really matter that it moved. But so it was x squared plus 6x plus 9. b is 6. Half of 6 is 3. Actually, let me write it to show you. So I'll put it over here. All right, so we want b divided by 2 squared. All right, so b was 6. We have it right there. So if we have 6 divided by 2 squared, that's 3 squared, which is 9. And we added 9. And in this case, continuing on here, okay, our b was 2, right? So b divided by 2 squared, there's b, is 2 divided by 2 squared, which is 1 squared, which is 1. What we added, I don't know wherever the 1 is, but we added a 1. And then the last one here, we had b divided by 2 squared, our B, we didn't write it down here, but I'll put it here. Our A was 1, our B was 8, and our C is 16 there. And 8 divided by 2 squared is 4 squared, which is 16. Exactly what we added. All right, so that's always going to be the magic number to make it a perfect square. And we just showed you here with 3 examples. In the next podcast, we're going to be using these steps to solve some quadratic equations. All right, because I think that is my next one, is to solve a quadratic equation. Yes, it is. So bye for now. And now we're going to, the next podcast, we'll solve this one.